Today I thought we would look at this industrial power supply. They come off of an industrial controller. As I mentioned before, I have some CNCs up in operation that I have upgraded in the past. I do put PLCs in them sometimes for controls, but mainly for just some extended I/O and some drill machines. Very few are actually a Rockwell Automation part. The small company I had, I did mostly deal with Automation Direct, more of the brick type PLC. Today I just thought we'd look at this controller power supply because we have multiple outputs on the supply. We'll open this up and take a look at it. I was hoping it would actually be an easy cap replacement, but none of them actually seem bulged. None of them obviously look faulty. That's a couple interesting things to point out on this board. One thing that I don't know if I've ever seen it before, we have an actual 6-pin SMD resistor that's got a 000. It's not that uncommon to see a little 0 jumper, but to actually see a 6-pin is a little bit unusual. As we look on this board here, we see that there's actually a lot of the 6-pin resistor packages. We actually have some 103, some 10,000 ohm. That's 10 and 3 zeros. We actually have a couple 105s. So 10 and 5 zeros is a meg ohm. I think that one there and that one there both. They both say that they are 105s. So that's kind of neat. So as we look at this board and what to check, one of the first things I do, our input power is fine. So, we got a switch, a fuse. There's some simple input things that will be quick checks. That will be an easier fix. We do see some power devices on this heatsink. As we look, we also see our separation here. Our input, our AC input side, and then our switch mode output side. And as usual, there's going to be a transformer that crosses over as isolation from in to out. As it's pulsing at high frequency, it's going to be isolation through this transformer. So on the input side, even though we know that we're getting our input voltage, and I know that when I hook the power up and I cut the switch on, you can hear something going on with this like a sizzle. So I'm going more towards a cap. Now it could even be the input cap. I don't even know if you can see it well on video, but there is a very large filter and input cap up under this large heatsink. And it's not bulged or anything. No physical indicators of any failure. And I was kind of thinking, well, that's going to be a pain to get to if you have to change it out. But if you look at this heatsink, it's actually bolted on, and they machined or cut out here. I don't know if you can see, it's kind of a horseshoe pattern. And believe it or not, it's right over that capacitor, so that's pretty neat. If you did have to swap that cap out, which will be one of your first failures, will probably be caps on these boards, that or a current carrying device like a transistor. But we can check that. We can check on the output side here. We can check all 6 of these caps, which it looks like all 4 of these are in parallel, and maybe these are too. This may be the 5-volt rail, but they're apparently different voltage rails. Because here's your output side where it actually plugs into the, we typically call it the back plane. But the first thing we'll do is we'll just get some capacitance checks. First one being the big input. It actually states it's a 400 volt, 330 microfarad. So a lot of times the size of electrolytic cap is due more to the voltage. You know, obviously the more microfarad, the higher capacity is going to be bigger, but typically it's more voltage due to your distance and your actual dielectric material. But your higher voltage makes it thicker when you wrap it. So see if we can get close to 330, just reading with the meter here. Yeah, and we're well over, so we definitely have some capacitance there. We'll check these. Shows over 2,000, which I believe those are 1,000 microfarad at 35 volt. These are the same. Those, as far as the capacity checks good. So we'll check now and see if this other output supply, see if these 1,000 microfarad, see if they're actually in series or are they parallel. But that is odd, it's showing 3,000. And it's 4 of them. Should be showing 4,000, so although it was acting more like it was maybe had some series resistance. We'll bring over the Esr meter. I'll check across these first, but I believe they're okay. So we're showing that for 25 volt nominal cap that the Esr is good. Let's go with this one. Good. All of them show good on the Esr. Whoa. I do see something there. Comment below if you saw it before I did on camera. We look real close. That capacitor right there. But repairing electronics, you're going to find that a good bit. Sometimes it ain't even the component, it's more of how it's put together or a solder issue. Because even though the quality control is typically good, there is going to be some misses. I hope you can see it on camera okay. That pad has actually never had solder on it. It looks like as it was going through the process, the solder stuck to the actual lead of the cap. It actually didn't stick to the plated through hole at all. If you look at the other lead on that cap, it's a terrible solder joint, like it's cold itself, but it did take. As we look here, there's another solder joint that it could be a lot better. Right there. There's another one right here that's not too good. It's actually on the switch. And it is being used, but you can see some solder made contact on this side. I will hit it with a soldering iron though. But I mean, I don't think it's caused any issue. It is making. This one, however, is just sitting right in the center, and it's not even really making contact. If I push it, it is. So we can tell that these are in parallel, just as these were in parallel and showed 2,000 with the two 1,000s. These are 1,000. And it looks like it should be showing 4,000 and they're all in parallel. There we go, we got the extra 1,000 in the circuit. So we'll put some solder on that and a couple others. And we'll power it up and see how it does. I actually trimmed off the lead on that cap so I can actually clean up a little bit better around that pad. I just got some alcohol and a Q-tip. I'm just going to put a drop or two of flux. I'll put a drop of flux on this one. It was actually very hard to solder. There was something on the pad on that one and this one making it very hard to get the solder to stick to the actual plated through hole. So something was actually on the plate, and that's the reason it didn't want to stick. Even from the factory, something happened there. So troubleshooting this power supply. What I've done so far is I found this little voltage regulator board that shows some voltage outputs on the edge card. And with my finger on the board, you see how tiny a lot of these are, but I'm trusting the diodes because I checked all the diodes and they seem to be okay, so I'm trusting they'll be fine. At this point, I'm going to put 24 volts across the actual bus, which is right there on that cap, or those actual bus caps. I'm just using my power supply to put out 24 volts. But I did notice this chip right here, which is a operational amplifier, or op amp. It's getting a little bit toasty. I'll put in some thermal imaging of that right now. So as we take a little bit closer to this op amp, this is what we have here: single supply quad op amp. We got 24 volts going to the VCC and the ground on the 4 and 11 pin. This is the direction that it is on here. We see pin 1 designation with a dot. So we measure across. I do have my voltage, but that operational amplifier is getting very hot, so I'm thinking about maybe removing the output pins one by one off the pad if I can. It's going to be really small to heat it up, maybe get it off of there, but I'll give it a shot. See if it's one of the outputs or the chip itself is bad. I'll set up my Avon iron. I do have a secondary iron, that way I just keep the smaller tip on this one. I use one or the other. My favorite go-to probably is my little HEPA, but instead of swapping the tips out, I usually have one of each. I do like the display on this Avon. It's got the display, you can see it. It shows your temp and your set, and it's easier to set, but it takes up more room on the bench, and I don't get it out as often. Gonna try to lift up one of these pins at a time. Apply a little bit of pressure and heat sink at the same time. It looks like that bridge back, I really can't tell, it's so small. I'm just gonna get some braid. Just braid and see if I can get the solder up this right there around it. I can't tell. I do believe that the output number 2 on pin 7 is completely cleared. Cut on the 24 volts. My current's the same, about 0.18. Yeah, still getting warm, so that's not it. So I have about 170, 180 milliamps going through this chip. Let me take out output 1 up here. Put a little bit of flux on it. Now it looks like pin 1 is clear. Power supply on. My current's still up. 0.18 to 24 volts. Yep, still getting hot. We'll move on around to output 3. Output 3 pin up. Still 0.18 amp. Still a problem. The last output is output 4. I'll lift that pin and see if that's it. If not, it's going to be internal. So with all the output pins lifted, it's still heating up, still pulling 0.1 amps, 0.18 amps. So it is a faulty op amp chip. I didn't actually have another one to compare it with, but I knew the ohms across it was low, but it was some capacitance. These capacitors are across it on the VCC and the ground. So I really couldn't tell. So I removed that chip. Yeah, this little chisel tip is a lot quicker. At least all the pads look good. Well, except for one. Output 3 must have took the pad with it. Now with the board cleaned up and powered up, the current is down. I dropped over 100 milliamps on the supply. I no longer have any heat. So it took a little while to get some spare parts in, but I do have the quad op amp in hand now. I had ordered a couple of them. That's the LM224DG. I got the board prepped. I do have a microscope to make it a little bit easier to see. I'll try to bring the camera down to the actual board and try to stay out of the way as much as I can. One thing I want to do is try to scrape the solder mask off of that trace where that pad is broken. And just removing some of that solder mask, I might be able to stick the solder to it. So now I have a little bit of that solder mask removed on that trace that's at that output. So now I'm just going to put on some rosin flux. I'm going to put the chip in place. See if I can get enough solder on one pin to hold it down. Tack down. Now I'm just going to try to drag across the pins. Try to get this left side. I want to get this right side. Clean this up and look for any bridges. A lot of that ugly dark is just that rosin flux. So I think every pin stuck pretty good on that chip. I do know that output 3 ain't making the best connection, but it is reading coming from output 3 to that via that goes to that RP1. I will reinforce that output going across where that U is on U1, going through to that via, and then going on around to that RP1. It shows making through where I scraped off that the solder mask and got to the trace. There's some solder there, but I'll reinforce it with some more across. Overall, it looks okay. There's our 2.5 volt rail. It's good. Stay on the ground. Go to our 5.1. There's our 5.1. It's good. 3.3. Good. 1.2. And our 24 volt rail is good. So all the rails look good that I can check on this little regulator board. did replace this little op amp that I believe has to do with overvoltage protection. It was pulling over 100 milliamps by itself, so, and it was very hot as we saw on the thermal imaging camera. That and one of the caps in parallel on the 24 volt rail was definitely an issue. I think it was making and not making sometimes, and definitely causing some issues across that capacitor bank, like a bad capacitor would, since it had a bad connection on the solder pad. So now I'll put it back together. Always be careful when fooling with mains voltage. So as we look here, as we mentioned earlier, this is our rails. We have the 5.1 24 volt, 3.3, 1.2. With all the testing I can do right now, it seems to be okay. Hope you enjoyed the video. Hope you learned a little bit about checking the caps and what to look for in repair. If you liked the video, give it a thumbs up. Please subscribe, and thanks for watching.